So what I'm telling you to do, don't waste time on your tailstock. Don't waste time leveling your bed. Instead, do this. Alright, hey everyone, something new today. Now, this video is for you if you've purchased a Chinese mini lathe, like I did a couple of years ago. This is the Optimum TU 2004V. I've been very happy with this. It's been really good. If you've got one and you're trying to set it up, and you're going around YouTube, like I did, people will tell you things like how to set up your tailstock, how to adjust the gibs, how to deal with slop in here, how to level your bed or your ways. That's all fine and good, and I did all that. It was only later on that I realized I hadn't done the most important thing, and that was to cut a rod. And you have to do the cut with your rod unsupported, just sticking out like that. Because what you're trying to figure out is, can your lathe cut a straight rod, or will it cut a taper into the rod? Is one end going to be bigger or smaller than the other end? That's paramount, above everything else. Everything else gets adjusted to that. I spent time adjusting everything else, didn't do that. Now, I got away with it because I had purchased this thing. This is a test bar. This is an MT3 test bar, and it's designed to go into your taper. You take off your chuck, you stick it in there, and this is meant to be dead straight, and the hole is meant to be dead center. Because I had this, it actually worked out fine. I did a good job. If I hadn't had that, I would have failed. Now that bar is not dead straight. It's precise for the money. That's a new term I'm going to coin. Precise for the money. When I had it in there, it would give me about 5/100ths of movement here at the other end, which is nothing at that distance, but it was enough to sort of ruin what I was trying to do, the precision I was trying to get. So I compromised and I did it, and it was very good. The whole lathe has been really good, quite precise. Now afterwards, I was still thinking about it, and I realized that I needed to level the bed. So I did another video, and I tried to do that, and again I went to YouTube and I looked at all the usual suspects who do these videos, thinking that they knew what they're doing, and they would tell me to put a level here, preferably a machinist's level. I use this one, and check it, and then do the same over here. Now they're not really telling you to level it with the planet, with planet Earth. They're telling you to level one side with the other, and if you have a great big huge lathe, you might have feet, and adjusting them will cause the bed to twist like that. And you're trying to get it level. Okay, now I did do that, and I found I got a worse result. Things went out of alignment when I did that, so I reverted it and I just left it as it was, as I had already set it up. Now the mistake there is that you're going to level one side with the other. That would be fine if your lathe was absolutely perfect, and if leveling the bed with itself would then automatically put it in line with the invisible center line of your spindle. If they were all perfectly in line and parallel to each other, well, that would be fine. You'd be good. But if you have one of these lathes, chances are nothing's in alignment. So what I'm telling you to do, don't waste time on your tailstock. Don't waste time leveling your bed. And so if you do this and you find you've got a taper, you need to do something about that. Now, I came back to this just this weekend, and I did a couple of cuts, and I got 3/100ths fatter at this end than that end. And I thought, oh, I'll see if I can tweak that out and show you what I'm doing. Well, first I had to figure out where's that 3/100ths coming from. First thing I did was I wanted to get rid of any effect of deflection from the cut. So using aluminum was one part of that. But what I did was I went back and forth. I used the auto feed to go down, and then I would turn the motor off, disengage the power feed, and just wind it back like that. And I'd hear it dragging along, and I could then examine the line as well and see how it dragged. And then I would run it through again, just turn on the power feed and the engine, and away it went, and it would do it again. And I did that about 8 times. And each time I could watch the amount of material coming off, and it kept taking material off all the way to the last cut. But it got finer and finer and finer until it was just dust. And so the idea of what there was, well, If I let it do that, that'll get rid of the effect of deflection. I had a beautiful finish too. After that was done, I measured again, zip, 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 all the way along, and I got the same size there as there. Success! Everything's perfect. But in the middle it was not. I was getting 1 or 2 hundredths of variation along here. I decided that it was being caused, I drew this because I've done this video 50 times. This saddle here, right, is sitting on a flat surface back there and on the sides of this V at the front. If you have a Sieg lathe, you just have those two surfaces. This lathe has an extra V and an extra flat surface there. Those are for the tailstock. Now, between that surface and the cutting tool, you've got, there's the flat surface, there's the V, here's your cutting tool. You've sort of got a triangle. It's almost equal-sided, almost. And so you can imagine that if one side has any variation up and down, or the other side, pretty much 1/100th down there is going to move that out 1/100th. And 1/100th out is going to be 2/100ths off your diameter, or on your diameter, depending on which way it goes. And two surfaces that may have some unevenness will cause that. So that's what I thought was happening. Now I was able to confirm that by mounting my test indicator on the actual slide back here, and then putting the tip in line with the tool and running back and forth, just watching it. And when I did that, there was no variation. It was perfect because the tool was moving along with the dial indicator, and any movement was reflected in the measurement. So it's perfect. But if I then offset the point here by 1 inch or 2 along the rod and then moved it along, that variation would come in, and I could see it just moving very, very slightly. That's what's going on. There's a little bit of unevenness in the movement of this thing up and down. No problem. It's very slight. The main thing is I wasn't getting a taper. If you've done this with your lathe and you've done your spring passes and you're still getting a taper, you need to get rid of that. And the way you're going to get rid of that is with this leveling feature. Now, instead of setting it level to the planet or level to itself, what you're going to do is forget about your level. You're going to twist it on purpose. So using shims underneath where you've got your lathe mounted on your bench, if you've got a Sieg, I think you've got 2 bolts at either end. The Optimum just has 1 bolt, but even though it's got 1 bolt, it still has a wide foot. And so you would loosen the bolt, put a shim under one side, and tighten the bolt, and always try and get it back to exactly where it was, roughly the same amount of torque. Because as you torque it up, you are twisting it. And you just need to push a shim underneath up against where the bolt is. You don't have to make a washer or anything. Just get some cheap automotive feeler gauges, get a whole heap of them, and use them to do that. And so you're just going to twist the bed one way or the other so that as the tool moves over here, the bed may shift it this way or that way. So you'd put a shim under the front to move it that way and make the cut tighter. You'd put a shim under the back to twist the bed this way to make the taper larger. That's what you're going to do. So once you've done that and you're happy with it, your next bit is your tailstock. Now with the tailstock, what you're trying to do is make sure that obviously the center line of the tailstock is exactly on that same invisible center line down the middle of your spindle. So how are you going to do that? How are you going to get this in a line with that? You might think you're going to put a chuck in here and just drill a hole and then you're fine, but you're not, because if this is not centered, well, your hole is going to be who knows where. And so what I did was, instead of drilling and then not being sure where the hole was going to be, I used a 2-flute, one of these plunge end mills, and I put that in my ER32 holder here in the tailstock. And now if the tailstock was bang on, obviously this would make a hole in the middle. But chances are it isn't, and if your lathe is new and hasn't been set up, well, no, it's not. It's not on center. But the idea here is that we're going to use this like a boring bar. If it's off center, if this is off that line, well, one of the flutes is going to do the cut and the other is not. The other will cut the depth of the hole, but it's not going to cut the edge of the hole. And all we need is the edge of the hole to be precisely concentric to that invisible center line, because that's going to sit on this slope right there. So I did that, and same as when I did these spring cuts, I just did it very carefully, pushed it in, I went back and forth and back and forth and back and forth, very light cuts until I got my depth that I needed. And that worked very well. That hole is dead center. And what we're doing there is we're creating a bar like this commercial product. We're creating one that is unique to this lathe. So it's bang on, it's cut live, and it's bang on. This here was pretty close, but not bang on. So the next bit is you've got your hole, that's centered. Now you can put your live center or your dead center back in here and adjust this to that. And what you're adjusting, of course, here is the horizontal movement back and forth, the twist of it like that, and the same up and down, and the seesaw like that. So there's quite a bit that you need to adjust here. The only adjustments that are available are, you do have a couple of grub screws either side of the base, and I have found the best way to adjust those is to put an Allen key in each, get them tight, and then always adjust them the same together like that. And there's one extra screw at the very rear which holds that in place. It locks that. It's designed to lock that. But the way those work and the way this whole thing fits together, it's pretty sloppy. You just need to end up with it quite tight. But you're not going to set that one first. The first one you need to set is the up and down, because that's not actually adjustable. If it's too high, you might have to file off something. If it's too low, you're going to have to shim it. Now, if you did watch my long videos, you'll know that I spent a lot of time shimming this. And I just happened to get it nearly spot on, so it was good. It took a lot of back and forth, and I was using that test bar, and it worked. I did a good job. And I did have to shim it, because out of the box, it was too low. Now, because of the way this works, and you've got all this motion, this thing can go in and out by at least a couple of inches, you can't just set it up at one end. You also have to set it up at the other end, because it needs to go out in line with that invisible axis in both directions, up and down, left and right. And that can be fiddly. So I have shims both at the front of this tailstock and at the rear. And I would again suggest get some automotive feeler gauges and use them at the front and rear to get it right. And so it's very simple. You go to one end, you put your test indicator on top, you're going to go like this, you bring this down to its lowest range, get up close, lock it, and then in you go. There. See that little bit of movement there? That's the difference between the hole that the end mill cut and this piece here. And you should also spin if you've got a live center, spin it around, see if it changes, just to make sure your live center is accurate and so on. Depending on which way that needle deflects, you will need to go up and down, first at the front, but then also at the back. You will need to go all the way out here, wind the whole thing forward, and do it again at the full extent of its range, which is a couple of inches. It's quite a long way, so somewhere around here. Lock it down, and in we go. Let's watch the needle. It's pushing it down down 1/100th. So you could say that this piece here goes down 1/100th over its range. So if I was going to shim this, I'm not going to, because that's virtually perfect. I would need to put a shim in one end, tighten it all up again, and then test that again. There we go. You should also check, when you just bring it on slightly, whether this knob here, the lock, does anything to it. What I've found is that at extension like this, it doesn't affect it, because it's affecting this end of the rod, of this rod, whereas that end is being held by this. If we do the same at this end, well, then this locking mechanism is much closer to the tip, and it affects this end of it. And it does. It can affect it by 1/2 to 100th, but it's worth checking. And then you'll do the same for this movement, back to front, using those grub screws. All right, I think that's everything I wanted to go over. Yeah, thanks for watching. Any questions or experiences with your own lathe, let me know how you get on. And like, subscribe, share the video, all that good stuff. Okay, see ya.